3, 2, 1. So I did a candy skull in the last video that I did, and I just thought I would do a video to show you how I did the cam in Fusion. So I will capture my screen obviously, otherwise it's going to be a bit freaking pointless. Let's start a new one because I have actually already recorded all of this, but I decided not to record any of the audio. So I'm going to start a new sketch. I know the piece of stock that I'm going to use is going to be 200 by 300. I know that it's 18mm thick, but I'm only going to extrude it to 15, and you'll see why in a moment. So I'm going to extrude this 15mm. There's my stock. So I'm going to insert a SVG file. Onto the front of here, move it up, scale it 1.75, move it up into roughly in the center of my piece. There we go. Click OK. There we go. There it is on the board, and you've got all your geometry. I'm actually going to add a bounding box just above and below, and you'll see why I did this in the when I come to do the cam. Finish the sketch. There we go, ready to go. Go to design, go to manufacture, and first thing we do is we want to do a setup. Click setup, milling. My orientation or my origin I always have in the center, because then it allows you to draw your diagonal lines and you can just line that up perfectly, but you can choose to do that however you wish. In the stock, none on the sides, and I'm going to add 3 to the top. That takes the 15mm of my drawing, and then the 3mm of my actual stock makes 18mm thick. Reason I'm doing that is because at the moment I don't have a spoil board, so I know that my machine is slightly out of kilter in towards one of the corners. So if I face this down, then everything will be in line with the machine. Click OK on that. The first one I am going to do is I'm going to do a face. I have a tool set up, a cheap Banggood 30mm facing tool. I tested it out earlier. It's actually pretty good doing this. My geometry, if I select the box that we drew earlier, that means it's only going to do the facing within the bounds of this box here. Because I fixed my stock at the corners with screws, this will negate it getting hit with the bit when it's flying through. Click OK, and there it's done. Put the face in program. So the next one we're going to do is we're going to do a 2D trace. I'm going to select my tool, and I have made up, it's called a tapered mill bit, but you can set it up in respect to for V-bits. So this is not a 90-degree V-bit, this is a 60-degree V-bit. I just decided to name it wrong. So we select that as my tool, and then if we go to geometry, and it's time to click all of the lines. So I try and start at one side, work my way over in a fairly methodical pattern. You can see I'm not actually selecting all of these, mainly because it's my artistic license. When you come to do the actual V-bit milling, you might find that you can't go deep enough to actually make them stand out, and if you do go deep enough to make them stand out, then you will go over or cut into other grooves that you've made, or V-grooves that you've made. So it's a little bit tedious. There's probably a quicker way. You can probably click and drag, but I just stick to what I know for the moment. There we go. Oh, we'll just do these. Have a quick scan over. Just make sure you've selected everything, otherwise be a bit of a nightmare. There we go. These ones as well. Click OK. Wait for it to So if you were to simulate as it stands here, it will simulate without doing the facing option, obviously, because you've only got it on the trace. Problem with that is that when you simulate it, it looks really deep, but that's because it's doing it from the top of the stock, as opposed to having the mill done and then doing it. So if you close that down, make sure when you do it, if you simulate it, do it from the setup one, simulate it from there, go over to the next operation. So we've taken off that bit of stock, we've milled it down 3 mils, and then play it from there, and then you'll get a much better representation of what it's doing. Notice is that it hasn't actually taken anything off. So what we can do is we can alter that, because it's going from the top. We edit that and we go to passes and we do a -0.5. We go OK. Same thing again, go back to your setup, go simulate, go to your next operation, play that, and you'll see now we've got a groove. There we go. Once you're happy with that, you can export your post-processor. So because I'm just starting out, export these as 2 separate sets of G-code. That's just my preference. I haven't got into the tool changing area yet. I still haven't got a spoil board, so that's a bit far of a jump ahead. There is a MPCNC post processor for Fusion 360 on GitHub. I'll leave the a link in the description below. When you export them using this, what I have found is, and then give it a name. I'll just call it that one. Facing 30mm G-code. When you the file comes open, you'll notice there's a line of code in here. So when the program starts, no matter where your bit is, that will set it to that point being the X and the Y and the Z zeros. I like to set mine manually before I start, so I'm able to move. I can move the MPCNC head up and out of the way to make any final checks. Unfortunately, if I then start the code, it will then make that my new 0. So what I like to do is I like to just take out that line of code just there and then save it again. And then do the same with your trace. Post processor, post it, save it as your trace, take out the line of code, save, then you're ready to go on milling. Thank you very much.